Hello, everyone. Thank you for taking the time to attend this session today. My name is Arti Raju, and I lead our solutions architecture team at AWS. And my role here is helping customers like you accelerate migrations and modernization using VMware Cloud on AWS. If you or your company are looking to migrate your applications to the cloud or want to maintain a hybrid environment, then you probably are wondering, how do I plan this architecture using VMware Cloud on AWS? What I also want you to think about as you design such critical architectures is how do you incorporate resiliency during this planning phase for mission critical applications instead of spending time later on thinking about this. What I wanted to share today is architectural patterns, lessons learned that you can take and utilize as you are migrating to the cloud. We'll also talk about what are some of the critical questions to ask when you're planning these architectures. This is an architecture session, so we'll not be diving into the service itself, but rather focus on the design patterns that can help you build hybrid architectures and plan for resiliency. With that said, before I dive in, I want to quickly level set on some of the building blocks in these architecture slides that we are going to be using throughout this session. AWS has the concept of region. So you'll see these building blocks throughout the slides. We start with a customer's data center, which is a typical data center that a customer has, and they're looking to migrate some of these workloads to the cloud or maintain a hybrid environment. And then the next is the concept of region, which is a physical location AWS has around the world. Each region consists of multiple isolated availability zones. You'll hear me refer to these as AZs. So an availability zone is basically one or more discrete data centers with redundant power, networking, and connectivity to an AWS region. So within the AWS region, customers can launch a virtual private cloud. So this is basically your own dedicated private cloud on AWS. You define your IP space and launch instances or servers into this space for your applications. The VMware Cloud on AWS also resides within a region you select while launching your VMware Cloud on AWS software-defined data center. You'll hear me refer to this as SDDC. So the SDDC is the VMware software that is powered by VMware Cloud Foundation. So VMware Cloud on AWS integrates compute, storage, and network virtualization products, which you probably are already familiar with. For example, vSphere, vSAN, and NSX, along with the VMware vCenter management. The next building block you will see is the NSX Edge. So when you bring up your SDDC, the NSX Edge is part of the deployment. It enables you to terminate any traffic that comes in or out of your SDDC. The next is the customer gateway. This is the router or firewall in your on-premises network. This could be, for example, a Cisco ASR or a Palo Alto network device, etc. We then move on to the virtual private gateway, VGW. A virtual private gateway is the VPN concentrator on the Amazon side of the network for any site-to-site VPN connections. So you can create a virtual private gateway and attach it to a VPC from which you want to create a site-to-site VPN. So if you think about this, the customer gateway sits on your side of the network on premises, and the virtual private gateway sits on the Amazon side of the network. We then have the AWS Direct Connect. So this lets you establish a dedicated network connection between your network and one of our AWS Direct Connect locations. So this uses industry standard 802.1q VLAN tagging with BGP, and you can establish dedicated capacity of 1 gig, 10 gig, or 100 gig, which was launched very recently. You can do this directly or through one of our AWS partners. We'll talk later in the slides as we look into network architectures of how this networking becomes a critical component during migrations. We then have an elastic network interface, which is commonly referred to as ENI. This is a logical networking component within a VPC, and it represents a virtual network card. So it can include the following attributes such as your private IP, your public IP address, a MAC address, etc. We then have the AWS Transit Gateway. So this connects VPCs and your on-premises network through a central hub. So think of this hub as the gateway that's managed by AWS. So this simplifies any complex peering relationships that you might be having. And throughout the session, you're going to be seeing this orange design bubble in every slide. So this is an architecture session, and the design bubble will talk about the considerations and some of the key questions to think about for that architecture. With that said, as we start planning to build these hybrid architectures or migrations that you are going to do, a key architectural piece is getting your networking right, as this will play a key role in migrating your applications or maintaining that environment both sides. There are a couple of key architectural patterns that I want to show you here. So the first architectural pattern is connectivity between your on-premises to the SDDC. So if you look at this, you're familiar with the building blocks that we talked about. We've got the VMware Cloud on AWS, we've got multiple SDDCs, and you've got your on-premises environment that you want to connect to. So customers can start with VPN connections. So on the SDDC, you've got the NSX Edge that can terminate VPN connections. On your on-premises, you might have a customer gateway device that can terminate these VPN connections. Key things to think about as you're designing, especially when you use VPN connections, is this is a layer 3 connection. So this could be either a route-based or a policy-based connection. We typically recommend customers to use a route-based VPN connection. As you plan for this architecture, some of the key things to ask is, how am I going to architect for resiliency? How is high availability achieved here, and what performance am I looking at? So performance can be limited by various factors. You have a single device on premises that can do up to certain gigabits of VPN bandwidth. Similarly, on the NSX, it can handle up to certain number of packets per second and bandwidth. So we recommend customers to determine what your requirements are and test it with the NSX Edge to see if that fits into your requirement. NSX also supports equal cost multipathing ECMP, so you could scale your bandwidth to a considerable amount. So as we move from this architecture into hey, I have a requirement for more bandwidth, this is when we see customers exploring the Direct Connect route, especially for large scale migrations. So Direct Connect, as I mentioned, if you as a customer are ordering a Direct Connect, AWS will provide you a letter of authorization that you can then take it to a common location, like for example, a level 3 or Equinix co-location, where AWS has a device and there's a cross-connect done between one of your devices and the AWS. So when you order the connection, you select what speeds that you want. So this gives you that dedicated bandwidth, which now we move, if you think about the previous architecture and this one, so you now have dedicated bandwidth. Like let's say you have a 10 gig link, you have a 10 gig link between your on-premises to the AWS network. Direct Connect, when you order a Direct Connect, there's a cost implication to it. So now you pay for the port charges of the connection. So depending on the speed, there is a cost associated for the port. And ingress data transfer is free. Egress, it's a much lower rate than the internet data transfer charges, but there is a cost associated. So we look at this architecture here. We've got a single Direct Connect location. So what happens if there's something wrong at the Direct Connect location? You don't want your traffic to be a black hole. So we recommend customers, as they think about scaling this architecture, to move into a similar architecture that you see here, with having multiple DX links that provides you that high level of fault tolerance. So if DX location 1 goes down for some reason, you still have traffic that can go through the other DX location. And the other thing is you can also prioritize traffic, which links to be preferred using BGP communities like ASPath prepending. For customers who do not want to have multiple direct connects, if cost is a consideration, we do support VPN as a backup. The only caveat to this you need to understand as you build this architecture is when you have a 10 gig link and then you step down to a VPN, there's of course like the bandwidth change. So you need to plan your architecture such that it's not impacted for these changes. So we talked about the on-premises to the SDDC connectivity. And then as you build these multiple SDDCs for different teams or different application, There's a couple of ways to connect this. One, of course, the same site-to-site VPN connection works. NSX Edge is available on every SDDC. You can create a VPN connection between these SDDCs. Whenever we talk about VPN, the same design pattern applies. So it's a layer 3 VPN. You talk about bandwidth and what your requirement is from bandwidth. There's also a number of VPN connections that each SDDC can support from the console and through the API. The next communication is between your SDDC and native AWS environment. A number of customers like you have told us, hey, I'm running workloads natively in my VPC, for example, a managed database with RDS. How do I connect my VMware workloads into this RDS that I'm running in my VPC? So when you create a VPC, there is an onboarding workflow that actually connects your SDDC into a VPC using an Elastic Network interface. So an ENI is created in your account and attached to the ESXi host running inside the VMware Cloud on AWS account. And all this heavy lifting is actually taken off your plate, so you don't have to go set it up. It's done during the onboarding workflow through a CloudFormation script. So as you look into this architecture here, you've got the Elastic Network interface is based off the Amazon network adapter. So you get the speed depending on the type of instance, like for example, i3 Metal with 25 gigabits of bandwidth. And then from a cost perspective, when you transfer data between like your SDDC and an RDS instance in the same availability zone, you don't actually incur any data transfer charges. If it's in a different availability zone, then you incur the standard cross-AZ charges. We also see customers move into this kind of a pattern here. So they also look at using VPN connections between their native SDDC and the native SDDCs and also their VPC environment. So as you see here, we've got the NSX that's capable of terminating a layer 3 site-to-site VPN connection. And on the Amazon side, as I mentioned earlier, it uses a virtual private gateway. So this architecture works for customers who are building out like a service insertion or a transit VPC kind of architecture where you need VPN connections. So as we think about scale, we talked about a lot of these VPN connections, and we know it is difficult managing these VPN connections. So we worked with VMware to introduce VMware Transit Connect, which is basically based out of the AWS Transit Gateway. So the Transit Gateway is part of the AWS Hyperplane architecture, which is powering a lot of our other internal services like Network Load Balancer, NAT Gateway, EFS, etc. So what this means is, so as you see in this diagram, the VMware Transit Connect is launched as part of your VMware Cloud organization. And then you can attach your SDDCs to this VMware Transit Connect. So as you see here, you can attach up to 20 SDDCs right now. And these are not VPN connections. These are direct attachments into the VMware Transit Connect. What this also helps you to do now is attach your own VPCs instead of, again, using VPN connections directly into the Transit Gateway. The Transit Gateway is a highly scalable gateway that's maintained by Amazon. It supports high bandwidths, and we have limits published on what the burst throughput is and what your combined throughput is. And as you think about it, we've kind of sorted connectivity from SDDCs into Transit Gateway, VPCs into the Transit Gateway, and of course we need connectivity back to on-prem. So same thing, you could use a direct connect gateway back to your DX location using what we call a transit virtual interface that is specific for connections going in and terminating into a transit gateway from on-premises. So if you look at this architecture here and we take a step further, if you have multiple regions and you're building this architecture, so I have 2 regions here and I'm building multiple SDDCs, I brought up the VMware managed transit gateway that I attached to, and I also attached my own VPCs into this transit gateway. One of the workflows is if you want to communicate between your VPCs, the purple VPCs that you see here, which are coined as workload VPCs, using the VMware Transit Gateway, that data flow is not allowed. So whenever you're using the VMware Transit Gateway or the VMware Transit Connect, what is important is one end should be the SDDC. So if you look at this thing, so on premises, your SDDC would work using the VMware Managed Transit Gateway, whereas workload VPC to workload VPC, which are both objects that you own, the data flow is not permitted. So what we've seen customers use as architecture pattern here is create their own transit gateway in their AWS account and attach the VPCs to that. So the VPCs now have connections both to the VMware Transit Connect and also the customer owned and managed transit gateway. And then the DX location or architecture stays the same. We bring up the DX gateway, we attach it to the transit gateway. So this kind of gives you a full picture of how the end-to-end data flow works when traffic has to go between SDDC to SDDC within the region, and then also SDDC to your VPCs, and also SDDC to your on-premises. So now that we've understood some of the common networking architecture patterns, the next thing is we figured the connectivity. It's time to get ready for migrations and some of the best practices around these large-scale events. So as we dive into the migration side of the architecture, so as I bring this building block up, a lot of you are probably familiar with this construct in VMware called the VMDK, which is the virtual machine disk file. You can have one or more of these attached to your virtual machines, and they could be the storage for your applications that run on your vSphere VM. So with VMware Cloud on AWS, we make it seamless to migrate these VMs from your data center to the cloud. So if you think about it, there's no conversion of VMDK into Amazon machine images or any other additional deployment of volumes. You have identical hypervisor ESXi running on both sides, which makes this conversion easier. Now, we worked with VMware to enable these options that will help you to have the seamless migration experience depending on your use case. So we've got a tool set depending on your use case that will allow you to get from point A, which is your on-premises, to point B, which is the AWS cloud, and also back. We've seen customers migrate back and forth depending on what their business requirements indicate. So the joint engineering integration between AWS and VMware will allow you to do this migration and have compatibility between your on-premises vCenter server and also the vCenter server that you're running in the AWS cloud without any downtime. So we do have hybrid cloud extension, which is HCX, which is another option that customers could deploy when they want to do bulk migrations of hundreds, if not thousands of VMs. So you select the VMs that you want to migrate in batches, select when to migrate and when to cut over to the new infrastructure without having to convert one format into another or modifying like even your operations runbook. There are additional options listed here that you see. Site recovery, which is better known for DR as a service capability, which is an add-on that allows you as a customer to have DR protection for on-premises or even the migrated workloads. So we also have Cloud Endure, which is a native AWS solution that allows customers to migrate into native AWS services from on-premises. Last but not the least, another popular choice that we hear customers have been using for backup and data protection is using our ISVs, for example, Dell EMC, Veeam, Commvault, Veritas. So all of these solutions are validated and certified to run on VMware Cloud on AWS. So we also hear from customers that they also have many other data sets such as end user data that could be structured or unstructured that is required by their applications or their analytics team on premises. So we've designed a number of services to make this migration or ingestion of data into AWS easier. So as you see here, we have AWS Data Sync that allows customers to deploy a VM that you download from AWS, deploy it into vCenter on premises, and then choose a destination. And this could be EFS for NFS-based storage, which is highly available. And then we also have FSX for Windows for SMB type file systems, and then Amazon S3, which is highly durable object storage, which is all these three are popular options depending on what your data protection and data analytics needs are. We've also got Storage Gateway, which is commonly used for customers for data protection purposes with the file gateway. So it could be the volume-based or the virtual tape libraries. So this fronts Amazon S3 in the form of a virtual appliance that you can deploy on premises. and then export NFS shares to the VMs or SMB shares to the VMs through the storage gateway. And these seamlessly migrate to various AWS services. One thing I tell customers as we sit down to plan such architectures is to build for HA and resiliency while in this phase, as it makes it so much more easier for you to do it versus doing it when an incident happens. We want to make sure you're well architected. So with VMware Cloud on AWS, running on top of the AWS global infrastructure and managed by VMware, you no longer have to worry about the undifferentiated heavy lifting of infrastructure, hardware, and software maintenance. So both of us, AWS and VMware, are responsible for the infrastructure and underlying software and the configuration of the SDDC. So hardware failures and data center outages can happen, but there are also solutions available that can help you automatically failover. So you are responsible for leveraging these, and some of these are built-in capabilities that all you have to do is enable to protect your business critical workloads against regional and data center failures. So as we look at the resiliency side of things, a standard SDDC, which is not stretched, is one in which all hosts are deployed within a single availability zone. So VMware vSphere HA, the high availability, protects a standard cluster from underlying host failure. So when we have SDDCs with more than one node, it provides data redundancy through various configurations. So you can utilize RAID configurations along with failure to tolerate FTT, which basically defines the number of hosts and device failures that a virtual machine can tolerate. So you can choose to have no redundancy, which is RAID 0, or select a RAID configuration optimized for either performance or capacity. So VMware Cloud on AWS leverages the AWS partition placement groups, PPGs, for host placements within a cluster as well. So when hosts in a cluster are placed in separate partitions, a failure such as, let's say, a hardware failure, this impacts a single host instead of multiple hosts in a cluster. So this is automatically done by VMware and transparently without having for you to do any configuration. With partition placement group and appropriate FTT and RAID settings, you can protect your workloads from rack level failures. The recommendation for VMC customers is, if you want to have the highest level of resiliency, so for deployments of more than 6 hosts, configure your FTT to 2. We also get questions around RAID config. The best practice is to recommend RAID 6, which gives you good trade-offs between performance and availability. For workloads where infrastructure availability is key, you have mission-critical applications that you're running, we recommend configuring a stretch cluster, which is basically a multi-availability zone deployment where data is synchronously replicated to hosts in a different availability zone. So you see that we have 3 availability zones, your data will be replicated to 2, and we have a witness node in the 3rd availability zone. So this option provides your SDDC with an extra layer of resiliency. So to prevent data loss, customers should use dual site mirroring, disaster tolerance. In the event of an availability zone failure, what happens is vSphere HA will restart your workloads on the host in the other availability zone. We talked about the vSAN policy with FTT and RAID. So if you think about those two and then moving on to the free space option, the recommendation is to keep 25% free space for your SDDC cluster. So we've now designed the service such that your free space is now down to, whenever the free space is down to 20%, then the Elastic DRS, the distributed resource scheduler, will kick in and it brings up additional capacity. The third thing to keep in mind is to have regular backups. So you should have data protection all the way, and the way to approach backups in the cloud is to offload. So what I mean by offload is that you're not going to run backups and store it into the recent data store, which serves as your primary high performance NVMe flash storage. What you want to do is offload them to native AWS services, either using S3 or EFS or whatever fits your use case. You can do this through either the ENI that I mentioned earlier, the Elastic Network Interface Connectivity that is attached to each and every host, allowing VMs that can have access to S3, FSX, or EFS. So all of these are built into the service. So when you start consuming native AWS services, you do not have to spend cycles worrying about infrastructure monitoring or keeping things highly available. So what do you think about as a customer in use cases like this is to learn the capabilities of the native AWS services so you don't have to worry about investing time in how to optimize for cost savings. For example, right, we've got different options here. We've got FSx, we've got S3, we've got EFS. So learn the built-in protection that's available with these services. These will help you, and you've seen some of these listed here in the slide here. So these will help you automatically do that operations on your behalf. So that wraps up our architecture session here around migrations and resiliency. A couple of key resources for you to get started and also understand these patterns. First one is, this one talks in detail about what VPC should you be using to connect your SDDC and what are the different patterns around it. The second is you learn about the DR design patterns. We talked a lot about the connectivity. We didn't spend a lot of time on disaster recovery, so this one will talk a lot about the disaster recovery design patterns and options available to you. And finally, this one covers the resiliency best practices that you can implement in your SDDC today. So I hope this is helpful, and I'm excited to see how each one of you are going to architect for your business needs and migrate to the cloud. Feel free to reach out to me if you have any questions or would like to engage in a discussion around your architecture. More than happy to sit with you and learn about your architecture needs. Please don't forget to complete the session survey at the end, as this will help us build better content based on what you need. Thank you once again and have a great day.